Okay, so again, this is the third part for normal distribution. So today we are going to learn when do we change from binomial distribution to a normal approximation. Okay, so for some question, we started with a binomial distribution with n is the number of trial and then p is the probability of success. Okay, so if let's say n is less than or equal to 5, so for this binomial, we simply solve them using the binomial table. So solve using table, or you can simply use the formula for binomial. However, when n is larger than 50, we cannot use binomial anymore because if you look at your table is only up until 50. So if n is greater than 50, we have to approximate using the normal distribution. So if you look at normal, we have the mean as well as the variance over here. Therefore, we should use the formula where the mean is equal to n times p. So we're going to take the binomial, use n times p as the mean, and then for the variance, we have to use the formula for NPQ. However, we should be very careful because in binomial, we do know that this is a discrete distribution. Meanwhile, this is a normal distribution, that means this is a continuous distribution. So since you are changing from a discrete distribution to a continuous distribution, you should make sure to do something called the continuity correction. So we have to do the continuity correction before you standardize them. And after you standardize, we're going to use the table for our standard normal. Okay, so let us see one example to solve this type of question. Okay, so example 1, a fair coin is tossed 400 times. So find the probability that less than 230 heads are obtained. So we are actually interested with the number of heads. So let x be the number of heads. So a fair coin is tossed 400 times. So we do know the value of n. So n is equal to 400. Probability of success, so since this is a fair coin, the chances to get a hit is similar to the tail, which is 1/2. So we can easily write down x is a binomial distribution with 400 and 1/2. Okay, as you can see, the n is 400, so n is larger than 50. Therefore, we must approximate using the normal approximation. So we have to calculate what is the mean as well as the variance. So mean is n times p. So we're going to get 400 multiply with 1/2. So this is equal to 200. Meanwhile, for the variance, this is NPQ. So we're going to get 400 multiply with 1/2 multiply with 1/2. Therefore, this is simply equal to 100. So once you have the mean as well as the variance, write down in the normal. So x is a normal distribution with mean 200 and the variance is 100. So we started with a binomial distribution, but since n is larger than 50, we have to approximate using the normal distribution. Now let us try to solve A, B, and C. Okay, so A, probability that less than 230 heads are obtained. So firstly, we need to write down the probability first. So for A, probability for x less than 230. Okay, so for me, before I do the continuity correction, I prefer to have the equal sign. So x less than 230. So this one should be x less than or equal to 229. So less than, you simply minus with 1. So you're going to get 229. So based on our number line, this is 2 to 9. So I should start from here going to the left hand side. So whenever I'm doing the continuity correction, I should make it a little bit larger. So I should plus with 0.5 for this one. So that means by doing the continuity correction, this is simply probability for x less than 2 to 9.5. So I've done the continuity correction. Now we have to standardize using the formula x minus mu over sigma. So this one, change it to z. So z less than 2 to 9.5. So just now we have already calculated, and we already have the n where the mean is 200 and the variance is 100. So 2 to 9.5 minus 200 divided by the standard deviation. So this is sigma square. So that means sigma must be equal to 10. So this is simply probability for z less than 2.95. Okay, so we have standardized. So now we have to calculate the probability. So z less than 2.95. If you couldn't see the region, then that means please draw the bell diagram. So the middle part is 0. 2.95 is on the right hand side of 0. Less than, so that means this is the shaded region that I'm looking for. However, the way we read our table is always to the right hand side. Therefore, I should take the total probability 1 minus probability of z greater than 2.95. So this is 1 minus 0.00159, which will give us 0.99841. Okay, so that is for part A. So now let us see B. So let me write down the distribution again so that we don't forget. Okay, so exactly 205 head are obtained. So B, we are looking at probability for x equal to 205. Okay, so now we have to do the continuity correction straight away. So right here is 205. So this is what we want to find exactly at 205. So what we should do is that we should minus 0.5 and plus 0.5. So this is simply z in between. So 205 minus 0.5. So 204.5 in between 205.5. So instead of having x equal to 205, we have already do the continuity correction. So x will become somewhere in between 204.5 and 205.5. So I have done the continuity correction. Next, let us standardize. So this is 204.5 minus 200 divided by 10 less than z less than 205.5 minus 200 and then again divided by 10. Okay, so now this is 4.5 over 10. So this is 0.45 less than z less than 0.55. So I have already standardized them. So now let us calculate the probability. If you didn't know how to calculate the probability, draw the bell shape. So 0.45, 0.55 and somewhere right in the middle. The way we read our table is always to the right hand side. So we should take this one minus with this one. Therefore, we can get the shaded region. So this is simply probability for z greater than 0.45 minus probability of z greater than 0.55. So now let us see the value. So this is 0.3, so 0.3264 minus 0.2912, and the answer for this one is 0.0352. Okay, so let us proceed to C. Okay, so X is a normal distribution with 200, 100. Okay, so between 180 and 190 head are obtained. So for C, we are looking at probability for X in between. So in between, we don't have any equal sign unless we have the word inclusive. So in between 180 and 190. So let me change this one into the equal sign. So greater than 180, it should be 181 x. Lesser than 190, so this is 189. So on my number line, I have 181, 189. So exactly from here up until here. Therefore, I should make the area become larger. So I should deduct with 0.5. And then I should add with 0.5. So this is probability minus 0.5. So 180.5 less than x less than 189.5. Okay, so we have done something called the continuity correction. So now let us standardize. So this is probability for 180.5 minus with 200 divided by 10 less than z less than 189.5 minus 200 and then divided by 10. So this is probability between negative 1.95 and negative 1.05. So both of them are actually negative. So what can we do now? Draw the bell-shaped curve. You should be able to see that since both of them are negative, both of them should be on the left hand side. Negative 1.95, negative 1.05. So we don't have anything with a negative z value. Therefore, you should flip them to the right hand side. So this is 1.05, 1.95. So this is the region. So you should take this one minus this one. So this is probability for z greater than 1.05 minus probability of z greater than 1.95. So substitute the value inside. We're going to get 0.1469 minus 0.0256, and the answer for this one is 0.1213.